This is Module 13, Lesson 5, and we're going to look at concentration of solutions. There's not a whole lot of content at this point. It's mostly math, so we only have one slide dealing with vocab. You can pause the slide and give yourselves a chance to copy down the definitions so that you have those later, and then proceed with the video when you're ready. So you do need to know the definitions here of concentration, dilute solution, concentrated solution, and molarity. Now, the main issue that I have with students with regards to this is that lots of times I'll hear concentrated referred to as strong. Like if somebody's coffee is a little bit too dark, it's not got enough water in it, they'll say it's too strong. But in terms of solutions, we need to be careful about using that word. That word is usually used in reference to acids or bases, and so we need to say concentrated instead. Dilute means it's watered down. It has a large amount of water or solvent compared to the solute. Concentrated means there's a whole lot of stuff dissolved, and there's very little of the dissolving medium or the solvent. So just, be careful using those terms. Now, molarity is the most common way that we are going to calculate concentration. This exact, a definition and equation is on your reference table. It's on page 3, where you have your formulas, and it gives you how to find molarity. So you don't have to memorize this, but you do need to know where to find it. We're going to be calculating concentration with moles of solute per liter or liters of solution. So it's very important that we use moles on top and liters on the bottom, which means if we're given milliliters in a problem, you have to change it to liters. So we're going to work some example problems. You need your practice sheet at this point because it has the examples on it. So get a hold of that and then prepare to follow me for a couple of examples. Here's example number 1. It says IV fluid is 0.90 grams of NaCl in exactly 100 mils of solution. What's the molarity? So on our previous screen, we just had the definition of molarity as moles per liter. This is the way it shows up on your reference table. So if you look at our problem, we have grams and milliliters. We don't have either of the things that are required. However, we do know from our previous modules how to turn grams into moles. So that's exactly what we're going to do. We've got a little review mixed in here with it. We're going to work a mole problem first. We have 0.90 grams of NaCl, and if you remember from our older stuff, we can turn grams into moles by doing a conversion problem. 1 mole of NaCl is 58.5 grams. And remember how I got these numbers is I added up the mass of 1 sodium and the mass of 1 chlorine off the periodic table, and I have asked you specifically to round it to 1 decimal place. If you don't round it to 1 decimal place, then we're not going to end up with the same answers, and you're going to not get credit for it. So if we do the math on this, the grams cancels, and we'll end up with 0.01538 and a bunch more numbers, and that will be moles of NaCl. Well, if we have moles of NaCl, we can take this and we can put it up top here. Now, what I don't want you to do is I don't want you to round. To be proper, you should keep all of those digits. Either store the number in your calculator, write down as many digits as you possibly can on your paper, or just keep it in your calculator screen and see if you need it. If it's the next number that you need, you may not have to do anything. Because what we're going to do is we're going to put that on top of the fraction. So it'll be the 0.01538 and all the other digits on your calculator screen. And we need to divide that by the number of liters. Well, I can change milliliters to liters. Remember back in Module 1, we learned the prefixes, and many of you have learned before the expression King Henry died by drinking chocolate milk. So if you're at milliliter, that's here, you need to move to base. Base stands for all of the individual units without a prefix on them, like gram, liter, whatever. So we need to go from milli to liter, which means I need to move my decimal 3 spaces, and we need to move it to the left. So that'll be 0.1 liters. We do the math with that, we'll get 0.1 0.538, and then there's more digits, of course. So now it comes down to sig figs. Well, this has 2 right here, and this has 1. So we can only have the first digit. So that's going to round to 0.2, and then our unit of molarity is molar. It's a capital M. Do not put a lowercase m. If you put 0.2 with a little m, that means 2 meters, 0.2 meters. So it has to be an uppercase M. There's our first answer. All right, let's do the next problem. The next one says laundry bleach is a dilute solution of sodium hypochlorite. How many moles of solute are present in this many liters of this many molar NaClO? Well, we basically have a formula here. Molar or molarity is equal to moles per liter. Well, the liters we have, we'll go on the bottom, 1.5 liters. The molar is the capital M part, so that's 0.70 molar. And then what we're hunting is the moles on top. I'm just going to put in an X since it's kind of weird to write almost a word up there. If we solve for this, we'll end up with X equaling 1.05. This one's much simpler because everything's already in units that I don't have to switch anything. So now let's talk sig figs. This has 2. This has 2. Remember, this 0 doesn't count. So I can have 2. I can keep the 1 and the 0. What's next door is a 5. So that's going to round me up to 1.1. I got ready to write the 5 again. 1.1. What did we find? We found number of moles. So that'd be 1.1 mole. And then you could properly put the NaClO on there if you want to as well. Okay, so you have a few practice problems, 4 actually on your practice sheet, that are some version of this molarity thing. So what you can do at this point is you can either pause the video and you can work those 4 problems and then pick back up with the next example. Your practice sheet tells you when it's time to stop and return to the video, or you can choose to keep going and watch everything and move on to the next set of problems. So if you're going to pause, do it now, work 4 problems, and come back when you're ready. The next formula that we have is about making dilutions. It explains right here that dilutions, it's watering something down. So lots of times in chemistry, it'd be very common for us to have like some sort of a stock bottle of a solution that might be something like 12 molar. 12 molar is going to be a very concentrated acid. So let's say it's 12 molar HCl. That's hydrochloric acid. But we don't want to use 12 molar hydrochloric acid. And what we want to do is we would rather use something like 1 molar hydrochloric acid. So what we'll do is we'll take a little bit of this, pour it into a smaller container, pour just a little bit at the bottom, and then we'll add water to some point on here and water it down. And we can turn this 12 molar into 6 molar, 8 molar, 9 molar, anything less than 12, we could turn this into it. Well, this right here is a handy equation to do that with. It is also on your reference table. So if you find the formula for molarity, you should find M1V1 equals M2V2. It's going to come in handy again later when we get to our next to last module. So all we have to do with this is plug in a molarity and a volume, and another molarity and another volume. Commonly, the way the problems are going to work is it's going to ask you how many liters or how many milliliters of some sort of stock solution, something concentrated that you need to make some number, some amount of a lesser concentration. Now, I have liters right here, but we should add, like, you can use milliliter. It's kind of like in our PV over T problems. I can use milliliters as long as it's milliliters on both sides. So let's see how this works. Going back to your practice sheet, you have 2 examples. The first one says how many milliliters of a solution of 2 molar sodium chloride are needed to prepare 1.50 milliliters, that should be a little m, 1.50 milliliters of 0.560 molar NaCl. So what they're wanting to know is how much of the concentrated stuff do I need to make this much of the weaker, more diluted stuff? So what we're going to do is we're going to set it up, MV equals MV. You can put the 1s and the 2s if you want to, or you can leave them off. All that really matters is that I put these two numbers together and that I have the 2 with the variable. So we could put 2.00 times the how many milliliters. We're finding V. How much of this stuff do I need to make 150 milliliters of 0.560 molar sodium chloride? Now, what do? We divide both sides by 2 to get rid of it over here. It's gone. And V is going to equal 42.0 milliliters. Why did I put the 0 on there? Because I need it for sig figs. If you look at this, this has 3 sig figs, 4 sig figs, 3 sig figs. So 3 is less than 4. We go with 3. So add a 0 to the end, and the answer to this question is I need to pour out 42 milliliters. So sometimes the questions are asking you a little bit more specifically what happens. So if we were going to do this, what we would do is we would take a container and we would pour 42, right here, 42 milliliters of 2 molar NaCl. We would pour that in here. But we want to make 150 milliliters of solution, so then what we would do is we would add water until we reach the 150 milliliter point. So all of this would just be H2O, and the stuff down here would be NaCl. So how much water would you need to add? Well, very simply, you would take the 150 and you would subtract the 42 from it. So we would end up with 108 milliliters of water being added. So should you come across a problem that asks you exactly how to make this, excuse me, or ask you how much water you would have to add, you just simply find the difference. That's all that you're going to do. Let's look at our second example of dilution problems. This one says, how can you make 560 mils of a 3 molar solution? So these two things are going together if you start with a 6 molar solution. So this is kind of a question that's more along the lines of what I was just explaining to you. So we have M1V1 equals M2V2. Well, let's put two things together. We've got 3 molar times 560 milliliters equals 6 molar times some volume. If you divide both sides by 6, you'll end up with 280. So this is in milliliters. Because this is in milliliters, then this will be in milliliters. What this means is we need to put 280 milliliters of 6 molar solution into a container and then water it down until it reaches the 560 milliliter mark. So if you're asked something like this, just understand not only how to do the calculation, but the concept of how much water to add. So on your paper, you now have problems 5 through 7. So you have like 3 little examples of these, or 3 practice problems to try. The answers are on your paper. Once again, you can pause the video and you can work those 3 problems, and you can make sure that you can get the answers, and then you can return to learn about the next type, or you can go ahead and watch all the examples and then work all the problems at once. That's up to you. So if you're going to pause, go ahead and do that. So here's our last type of problem. This is about percent solutions. Another common way to give concentrations is to do it with percents. You'll see this sometimes with things that you buy from the grocery stores. For example, if you go buy a bottle of hydrogen peroxide, you'll probably see on the bottle, it'll say something like 3% H2O2. Or if you buy juice and it'll say something like contains 10% juice. It's common to see percents with things like that. Vinegar is another one where you might see this. What that means is they're giving you the concentration by telling you just parts. Like if it's 10% juice, then it's 1 part juice to 10 parts of water. Like a tenth of it is juice. If it's 3% H2O2, well, then that means it's 3% hydrogen peroxide and it's 97% water. Now there's 2 ways to do percent solutions. You can use percents with volume, or you could do percents with mass. Now this is about the 3rd time that we've had percentages as a problem, And remember that anytime that we do a percent, it is part over the whole times 100. So if we're doing percent volume, then we need part of the volume over the whole volume. If we're doing percent by mass, then we need part of the mass over the whole mass. So here's some examples. These two example problems are on your paper. I'm working one of each. The first one is a percent by volume. So it says, what is the percent by volume of ethanol or ethyl alcohol in the final solution when 85 milliliters of ethanol is diluted to a volume of 250 mils with water? So what we're going to do is we're going to take the part. The part, by the way, is always the smaller thing, and that should be a little m instead of a capital one. We're always going to put the smallest one on top. So that's going to be 85 milliliters over 250 milliliters. Now you can use milliliters or liters here, but they both have to be the same. So just don't do 1 milliliter and then 1 liter. And then we're going to multiply this by 100. So if we do that, you'll get that this is 34% ethanol. Now as far as sig figs, you go by these. Since this has 2 and this has 2, I want my percentage to have 2. Okay, so it's that simple. It really is. Like, there's nothing really more to it. Sometimes you can work backwards too. Like, I might ask you for the top, and you have to work backwards this way. Like if I give you the percentage, and then you have to solve for x, but that just comes down to algebra. Here's our last example, and this one's a percent by mass. What mass of ethanol is in a solution if it is an 8% solution with a total mass of this? See, this one works backwards like that. If it's 8% and it tells me the total mass is 450, then that needs to go on the bottom. That means we're looking for the partial mass up here on the top. So if you do this, most students will mess this up because they'll forget about the 100. So in order to start the problem, the first thing that you're going to have to do is divide both sides by 100 in order to get rid of it on this side. So when you do that, obviously, then that will become 0.08 equals x over 450 grams. Now you're ready to multiply those, and when you do, you will get 36. But let's talk sig figs. If this only has 1 sig fig, then I would only give this 1 sig fig. I know this one has 2, so do your percentages with the same number of sig figs as you have in the problem, and that means to answer it, we would need to say 40 grams. All right, you have 8 through 10, you have 3 more problems like this. And then what I have from that point is all mixed practice. So if you're at the point of finishing this last little bit, then once you finish it going into the mixed practice, you have answers for a while, and then the answers are no longer there, which means you're going to try your luck a little bit at whether or not you actually know how to do this. And then you'll have your answers when I give them to you, and you can compare to see how you did. So if you have questions, you can join me during office hours, and you can ask those questions, or you can send me a message, and we'll see what we need to work on. Good luck!